Hello everyone, welcome to this channel. It has been a while since I have posted a video on this platform. It has been around 5 years now. Last time when I was posting the video, I was not married and I didn't have kids. Now I have both. And I have also been busy on the job front a lot lately. So recently, since around 5 years, I've seen that every time I get into a conference, people do ask me about how to get into robotics. What's the roadmap like? I have been a robotics engineer since around 12 years. I also have a bachelor's degree in mechatronics, which is around robotics. I was interested in robotics since around 8th standard, where I got introduced to robotics from one of the labs, which was hosted by the school. So I have been with industry in this industry in and around 15 years down the line. Let me share the details with you regarding how, if you are a student today or if you are in college, how to get started into robotics and what's the roadmap like. So yeah. So most people think robotics is basically building cool toys, but in reality it is the intersection of mechanical, electronics and computer science. In India, we are moving past assembly into indigenous R&Ds. So here are the three pillars of robotics. First is mechanical, the body, which basically deals with physicality, movements and structures. Second is electronics, which basically deals with perception, power and communication. And third is software. It deals with logic, navigation and autonomy. Welcome to phase 2, the hardware foundation. Goal is basically to learn how things move and how they feel the world. So I'll quickly go through the topics which kind of are related whenever you're learning into robotics. So in terms of mechanical, the best starting point is CAD, which you could use Fusion 360 and SolidWorks as the software to design your robots. Then about microcontrollers in electronics, and we should know about microcontrollers and microprocessors. Level 1 could be Arduino, where you can learn the basics of PWM and digital analog IOs. Level 2 could be ESP32, which this is basically a crucial for IoT and wireless communications. Now level 3 is STM32. This is an industrial standard for high performance flight controllers like Pixhawk in drones and industrial bots. Now the third segment is around sensors and actuators. Basically in this you can get into IMUs, you can understand accelerometers and gyroscopes, LiDARs for mapping and encoders for precise wheel movements. And moving from hobby servos to BLDC motors with field oriented control is a must when we talk about industrial robots. So you should definitely check that out. Now let's move into phase 3, which is about software stack. Welcome to phase 3, the software stack. This is where the real money is. If you don't know the stack, you are just a hobbyist. So languages. First languages is basically you have to get into C++. Non-negotiable for real-time systems and low latency control. Even these days Rust is becoming very popular, and I think somewhere down the line Rust is going to replace C++ because it has better compiler, it has no garbage collector, so it kind of works much better than C++ in many scenarios. You should look into it. Then we're talking about Python. Python is basically for prototyping only, that is not so industrial in nature. Plus basically it is used in AI and ML itself and high level scripting. You should definitely check this out. Talking about the operating system, Linux, robotics runs on Linux these days. Learning the terminal and bash scripting and kernel basics is something which is very important. But I think from here on, from last 5 to 6 years, what I have seen is the robotics is moving from Linux to Android OS, where we are stripping down Android OS. We are trying to customize Android OS and pull the things out which we don't want and try to make sure that we boot very fast. So we'll be talking about all of that in the later stages of our course, and I'll get you deep inside the Android OS and how things are structured and well. So do subscribe to my channel so that you are also engaged and also get updates on all the videos which are coming up. Last is ROS2. ROS2 is basically robot operating system. This is kind of an industrial standard. Learning nodes, topics and services and actions is something which kind of gets you into ROS. Simulation wise, we don't break expensive hardware because we have ROS2. Master Gazebo and NVIDIA Isaac Sim. These are the two topics or the two tools of simulation of your hardware. So this kind of helps you go through all the permutations and combinations whenever you're learning even neural network. So, and last is computer vision, basically OpenCV for basic tracking, and then move into YOLO for object detection. So this is the end of phase 3. Now we're getting into phase 4. So welcome to the fourth phase. This is where we'll talk about Indian education and entry points. So the first question which actually gets asked is where to study. So generally there are 3 tiers. First we'll start with ISC. So ISC Bangalore has AI and Robotics lab, which actually is quite great and is also globally recognized. Then comes IIT Madras, which has Robotics Research Center, which is also working on some 120 different projects, and they are recognized across the globe. And the first is IIT Bombay, which basically has eYantra lab and is world class too. So these are the 3 segments where you can get into. But what you have to look for is basically specialized degree. Look for BTech in mechatronics and automation. As of now, what I know is even Manipal offers mechatronics as a course and also is quite great. Many other colleges like VIT and SRM have got into mechatronics and automation. So you can also look for that. It is basically a skill first route. If you are in a 3rd tier college or even 2nd tier college, then your degree matters less than your GitHub and portfolios. So the first thing is start coding. That's pretty much what will get you into this particular domain. So the actionable tip is basically to participate into DD Robocon and eYantra. These competitions are the unofficial placement hubs for Indian robotics companies. Let's get into phase 5. So phase 5 is about Indian job market and salaries. So the landscape is basically into 4 segments in India. First is warehouse logistics, where Grey Orange is one of the companies which actually work on that, and plus Adverb for high demands for navigation engineers. And then we have defense drones for Idea Forge and New Space Tech. And then we have in EV automotive companies, we have Ola Electric and Athar, which kind of are also taking mechatronics engineers a lot. Plus you can always get into automotive companies like Mercedes, Renault, or even Hyundai, which are always there. There is always demand for BMS and control systems engineers, so you can get into that. Plus in services and medicals, there's only one company which I think of kind of is worth looking into, is basically Sinel, and this basically works in vision and first robotics. Now the last phase of this video is phase 6, the exact learning roadmap which you need to follow if you want to complete at least the starting point of robotics. I think the timeline basically should be around what I have described. So this is the exact learning roadmap which we have, which could basically take you from knowing nothing to at least able to talk to somebody into robotics and also maybe get you a first job. In the first 2 months, you can definitely master C++. You can learn C++ from any YouTube tutorial, or even these days you can Google and you can get. For basic electronics and Arduino, you can always refer to my playlist, which is already available. You can check that out. If you want to know more about it, you can let me know. I can create more videos around basic electronics and Arduino. In the 3rd and 4th month, you can learn about Linux and ROS2 basics. So about ROS2, I have already created a playlist of ROS2, which is also there in the description. You can check that out. This is basically on ROS basics, how ROS works and how different nodes communicate with each other. So you can check that out too. In the month 5 to 7, you can buy a ESP32 or an entry-level Pixhawk. You can build a project like drone or rover, which kind of actually solves a problem. This is where you can be at around 7 to 8 month. And in the 8th to 9th month, you can get deep dive into SLAM, basically simultaneous localization and mapping and perception. So there is already a video in the description about how SLAM works in ROS. You can check that out. There are multiple different people who have worked on this too. You can always go and check out ROS2 tutorials. They are readily available. Then in the last month, basically 11th and 12th month, you can basically start contributing to open source like AOSP for robotics and ROS2 packages, and document everything on YouTube or LinkedIn, or at least have some GitHub account where you track all the changes which you have done and all the requests and pull that you have done. So that will basically help in people to understand your contributions in the robotics field as well. That is the most important segment. So this was a very highly dense but very quick video of robotics roadmap. It could be applicable to any of the students who is there in 8th standard to 12th standard, or even in college, or even if there's a professional, he can also follow the exact same route, and within a year you will be able to actually get into robotics industry. If you found this video useful, more links are there in the description. If you feel that you want to read more about the roadmaps and the different documents I talked about, they are all in the description. You can let me know. My name is Vaishvik, and I would love to see the machines that you build, and see you in the next one.